All right, today we're going to work on our goal of graphing this rational function, and we're going to take a look at it, and we know he's irrational because we have x's that are in the bottom. So I'm going to take a look at the degrees in the front, and the degree in the front is a 3 versus the degree in the bottom is a 2. So that means that our top is bigger than our bottom, and we will have to find the horizontal or slant asymptote by doing long division. So that's a must in this problem. Okay. First thing I notice, always A, I'm going to ask you to factor and simplify. And I'm looking at the top and there are 4 terms. So whatever method you do, I put them straight into the box. Okay, bottom has 3 terms, so x in the box. Whatever method you do, go ahead, hit pause, and go for it. I'm going to start factoring. So across the top I see that x squared comes out and -4, which instantly I see this, and I'm hoping you're starting to recognize x squared minus 4, and that becomes x minus 2 and x plus 2 in any order. And across the top I see 2x and minus 1. Okay, bottom. Multiplying these together, we get -6x squared in the top, trying to add to 1x. This is the one on the ACT, SAT that they'll always give to you. So we are going to do 3x, take away 2x. Okay, and I see x plus 3, x minus 2. And so instantly right there, I am seeing, as I put them into the fraction, that we do have a cancellation, which means that a whole is going to exist right here at 2. So we are going to take this 2 and we are going to plug into what is remaining. So break out your calculator. Again, we're going to hit pause. Okay, and don't forget your parentheses. I'm going to plug it right into here. So I see we are going to do 2 plus 2 and 2 times 2 minus 1. And I'm going to divide it by 2 plus 3. And we're going to get out 2.4. So let's go ahead to our graph right now and graph 2, 2, and a little bit more is a nice hole right there. It's a nice open circle. Okay, next thing that I see is that we still have a denominator. So if we have a denominator, that means for us that this is our vertical asymptote. So again, the vertical asymptote always comes from the denominator. And I see that we cannot plug in -3. So let's go right now and go to -3. 1, 2, 3. And the one thing I'm noticing that we're still struggling with is what numbers to plug into our table at the end. So I'm actually going to connect these two right here. They are connected. Because what I would like for you to start doing is going, okay, I have a vertical asymptote, and if I got -3, I'm going to plug in -4 and -2. So I'm picking values that are around that vertical asymptote. Okay, so take a moment and go ahead and plug in -4 and -2. And it does not matter if you plug it into the original or into our remaining factors. Okay, if you do into the original, let's make sure that you are putting parentheses all the way around the numerator, all the way around the denominator. Okay, so I plugged those in and I got out -18 and 0. And ooh, that 0 sticks out to me. That means that this is going to be an x-intercept for us. So that's going to be really nice. Okay, so we'll come back to that at the very end. Let's move on to our slant asymptote. Okay, again, we're going to have a slant asymptote because the top degree is bigger than the bottom degree. So we're going to have to set up long division. So I'm going to take a look through for any missing terms, and I don't see a single missing term. So I'm going to come over here and start our long division. Okay, so I can look at this two ways. I can look at what times the x squared gets us to 2x cubed, and I see 2x. Or I can look at it backwards, 2x cubed divided by x squared. Let me write that over here, 2x cubed divided by just x squared. And we can see out pops this 2x. Okay, and then I'm going to distribute, and get 2x cubed. They match, good, keep going, plus 2x squared minus 6x. And then I always recommend a separate color, something to make sure you are subtracting to find out what is remaining. Okay, and then we get minus 3x squared minus 2x and bring down the 4. So again, I'm going to look at it forwards. What times x squared gets me to negative 3x squared, and I see the negative 3. Okay, if you need to, look at it backwards. Negative 3x squared divided by x squared, and you can see the negative 3 come out of there. Now, this is all we need for our purposes, because that is the slant asymptote. We don't need that remainder, so we do not need to continue on. So mx plus b, and we are good to go there. Okay, so I am going to slide this back over to here. Okay, and our slant asymptote is 2x minus 3. So let's go ahead and start graphing that guy. So I have an up 2 and over 1. And instantly we can start to see that that hole pops up above it. Okay, and I'm going to make that line red. And the reason why I'm going to make that line red is it doesn't matter if this is a horizontal asymptote or a slant asymptote. You are trying to figure out if the shape is above this or below this. So the first thing I see is on this section right here. It's either above the red line or it's below the red line. You already have a hole that's above, so it's got to be above right here. And I'm noticing it's probably going to be crossing the x and the y axis as well. Okay, and then we're going to come over here and we're going to figure out if it's above or below. And you can already see you have negative 4 and you got out negative 18. That's way down here. So I don't really need that point, but you guys can take this point right here and go ahead and assume that this means that it's down here somewhere, and you're just going to make a shape down here to show me. Okay, now I do want to get some of this other information up here a little bit better. So the first thing we're going to do is the y-intercept, and you're going to plug in 0. So either use your calculator or use the beginning, and you can see 0, 0, 0. The top is going to be 4. 0, 0. The bottom is going to be negative 6. 4 over negative 6, which reduces to negative 2/3. Let's go ahead and graph him right there. And then something I would like to try to maybe make a little bit more clear is we do use, and let's go ahead and write that in there, cross multiplication to figure out, sorry, this should be flipped right here, to setting this equal to 0. And what that really comes from, though, is your numerator. So if we take a look at our numerator is already solved. That's better. Okay, our numerator is already solved because the cross multiplication, when we set this equal to 0, and if you want, you can put a 1 over it. Okay, when you go this way, those are going to knock out and become 0 every time, gone. So all that's left is the numerator, and you already have it solved. So take a look here. You have x plus 2, which means one of them is going to be at negative 2. And we can already see that here at negative 2, 0. So I'm going to come over here and mark negative 2, 0. Okay, and the other one I'm going to solve, this guy, is positive 1 over 2. So positive 1 over 2 about right here. And we can start to see this nice shape come in above the red line. Okay. So again, our whole point of doing this is vertical asymptote. Pick a point to the left and to the right of it. Okay. Horizontal or slant, it's either going to be above it or below it, above it or below it. And now we are completely done graphing this problem with all the information shown.